Good evening, everyone, and welcome to the UTT, another one of the UTT-SP's technical. This time we'll be doing, this is actually part 2 of our non-fuel usage of oil. This segment is on lubricants. Here today we have Mr. Kevin Motilal. So I'll jump into his bio right now. So Mr. Kevin Motilal has a Bachelor of Science degree in Mechanical Engineering and a Master of Science degree in Production Engineering and Management, which he earned at the University of the West Indies, St. Augustine campus. He has also obtained a master's degree in business administration from the Anglia Ruskin University. He's a certified lubrication specialist and certified oil monitoring analyst with the Society of Tribologists and Lubrication Engineers, or STLE. He is also a certified STLE instructor and a certified training instructor with the Society of Maintenance and Reliability Professionals, or SMRP. He is experienced in maintenance and operations of equipment in heavy industry and has 10 years experience specifically in the field of lubrication. He is currently employed at Trinidad and Tobago National Petroleum Marketing Company Limited, or NP, and holds the post of General Core Business Support, for which he is responsible for the strategic oversight of the LPG business, ensuring technical support, quality control, and quality management supports are provided to the company's operations. Also overseeing the business operations in Tobago and Dominica. He has also acted in the position of Chief Executive Officer at NP, a $3 billion per year contract company in a highly unionized environment from December 2013 to January 2017. So, ladies and gentlemen, please direct your attention to the share screen. Mr. Motilal, stage is yours.
All right, thank you very much, Mr. Cabrera. So, good evening, everyone. So, my presentation, of course, apart from all the other things that I do, so today I'll be focusing more on the technical aspect of my job. So I'll go through the presentation, and as you have questions, if you have any questions, I like to make it interactive. And as I was telling Brian a little bit earlier, this is the first time I'm doing a technical presentation online. So I don't know how it is already a boring topic, lubricants, but let's see how it goes. So if you have any questions at any point in time or you need any clarification, because I'll be using a lot of terms to describe lubricants, and because of course it is about lubricants, but it's not really a lubrication seminar. So I wouldn't be going into a lot of the basics, but I'll try to give an overview of it. So as I say, if you have any questions, feel free to ask. So the agenda for today, you've seen the screen change, right? Crude oils would be crude oils. I'll talk about lubricating oils and its components, how the components are manufactured, well, specifically the base oil part of it. I'll talk a little bit about greases. I'll talk a little bit about application, a little bit about specifications, and I'll talk a little bit about the lubricant market itself. So just to give a little idea and to bring it all together in dollars and cents, which is what we are all about at the end of the day. So lubricating oils. So normally when you hear people talk about lubricating oils, they normally mean anything. It could be anything from baby oil to hydraulic oil to turbine oil to oil that you could put on your dog, or it could be anything. And that's a general term, and of course that's to most people who are not familiar with the different types of oil. So it really is a generic term, and it really comprises of base oil. So 2 parts: base oils and additives. And of course the most common lubricating oils are mineral type oils, and these are the oils. So of course, mineral type oils are one type of oil. We also have synthetic oils, and they are plant-based or bio-based oils. Right, so you would have heard about the soya oil and those things, the rapeseed oil being used in equipment or some hydraulic equipment. This presentation, however, will focus on the petroleum-based or the mineral-based lubricating oils. So these lubricating oils are comprised anywhere from about 80% to about 100% of the base oils comprise about 80 to 100% of lubricating oils, and it's in different proportions depending on the different type of oil you're speaking about. So You have just the plain process oils, which are 100% base oils, and you have things like hydraulic oils, which are just about 0.5% additives. And then you have things like engine oils, which are anywhere from about 15 to 20% additives. And you have things like automatic transmission oils, and they contain a lot more additives because they're very complex. So you have very simple lubricating oils going to complex lubricating oils. So a little bit about the manufacture. So crude oils, well, of course, you know, they come from different parts of the world, and they have different characteristics and properties, and they classify differently. So basically, you have the paraffinic type, and you have the naphthenic type, or the aromatic type base oils. And of course, it's named after the predominant type of molecules. So refinery crude base stock usually consists of a mixture of both, depending on the type of base oil that they want. So most of the base oil used are paraffinic type base oils. And so they would tend to have or purchase more paraffinic type crudes, or they have to fix the crude, because remember, they manufacture, they don't actually just manufacture. And I'll talk about the manufacture a little bit later on. They don't just manufacture lubricating oils, they manufacture the fuels, which is where the bread and butter of any refinery is. And of course, the lubricating oils is an after step. So with respect to base oils, so there are a number of different base oils, and of course there are different qualities, there are different types, there are different manufacturers even of the same type, and they also give you different properties. And the properties are dependent on the properties of the crude, especially for the group 1 base oils, and a little less dependent as you start to hydrotreat and hydrocrack the base oils. So just to give a little overview, this is the API, the American Petroleum Institute publication 1509. And it groups base oils because, as I said, it became very complex. So they group them like this. So they say for group, they'll consider group 1 base oils, the saturates is less than 90%. Its weight of sulfur, or the sulfur weight by percent, is more than 0.03%. And the viscosity index is anywhere from 80 to 119. And of course, the process is using the solvent refined processes. The group 2 base oils are more than 90% saturates, has less than 0.03% sulfur. Viscosity index is similar to the group 1s, so it's 80 to 119, and they hydroprocessed, but lightly hydroprocessed. The group 3 base oils are more than 90%, less than 0.03%. However, the viscosity index is more than 120 degrees Celsius. And just to quickly give you an idea, well, we know what the saturates are, we know what sulfur is, and the viscosity index is the rate of change of viscosity of lubricating oils with temperature. So the higher the viscosity index, the less the viscosity changes with temperature. So you get a more steady viscosity throughout the temperature range in which the equipment works. All right, so that's the more useful thing to have, obviously. And of course, it's all dependent on application. To produce the group 3 base oils, it requires severe hydrocracking, and there's a group 2+ category, and that category is for medium hydrocracked lubricants. So it's somewhere between, the quality is somewhere between group 2 and group 3. The group 4 base oils are polyalpha olefins, and these are created by a chemical reaction. And so the group 1 to 4 are based on mineral or produced from crudes, which is where the focus of this seminar is. And the group 5 base oils are all the other synthetics. So you could have polyol esters, you have alkyl glycols, silicone oils. So all those other things fall into that category. So the base oils, so group 1, 2, and 3 base oils basically reflect the evolution of refining technology over the past 70 or 80 years. The group 4 base oils, they have existed for more than 50 years. They are pure chemicals created in a chemical plant. And so the group 1 to 3 base oils are produced using distillation and refining of the crudes, whereas the group 4 use the components from the crudes and they put them together in a chemical reaction to form the PAO molecules. So PAOs fall into a category of synthetic. They call them synthetic hydrocarbons, And they have a viscosity index, as I say, greater than 120 degrees Celsius. They, of course, are a lot more expensive than Group 3 base oils to produce because it needs a lot more processing to manufacture them. So a little bit about the base oil quality. Because, as I said, more than 80% of any lubricating oil is base oil. So the base oil does, in fact, have a great influence on the different a great influence on the lubricating oil. So some of the things are viscometrics, viscosity grades. So sorry, you have the viscometrics, so you have things like considered as viscosity grades. So of course the lighter lubricating oils you need to use lighter base oils, and of course heavier viscosities, you need to use the heavier base oils. The appearance is important. Color, cleanliness, clarity. Color, for instance, sewing machine oil. There's not something we take into consideration, and this is industrial sewing machines where you have you have the lubricating oils being used in the equipment, and if there's a spill for any reason, the oil can get on the clothes and then discolor the clothes, and of course you have loss of product. So those oils tend to be very clear and light, so it really doesn't soil the clothes excessively. Clarity, so some applications you need the lubricant to be clear enough so that you can see through it. Volatility plays a part, volatility and safety. So this is that property of the oil where you have, of course, especially when you heat it, you have the lighter ends coming off because you have the different molecule sizes, and you have the lighter ends coming off, and it affects your flash point. It affects things like your distillation. So you might have more of the heavy ends remaining. So if you have your lighter ends going off, you end up with a thicker base oil or lubricating oil because your light ends would have gone off, and that changes your viscosity, which can damage the equipment. You have things like compatibility. So depending on the additives, you need to use certain base oils because some additives are just not soluble in the different varieties of base oils. Oxidation stability, of course, this is temperature dependent, and the higher the temperature, the higher the rate of oxidation of the lubricant, and the higher the rate of oxidation, the more the oil sludges and eventually thickens. And you tend to hear this with people who didn't change the engine oils for like 2 years, 1 year or 2 years, and they say, you know what, that oil mash up my vehicle or mash up my engine because it didn't change it on time. The trouble is that it actually went past the working time and really wasn't changed on time once you're using a good quality oil. And of course, consistency. So your base oils, you're looking for a manufacturer that could produce consistent base oils. So the viscosity is not all over the place, it's within a tight band. So you know exactly what your manufacturing process is when you're manufacturing base oils. Any questions so far? Anybody awake? Everybody awake so far?
Yes, we are awake.
Okay, excellent. All right. Feel free to ask any questions if I'm going a little bit fast. You have any questions so far, though? Nope. Take that as a no.
We have a question.
Right. Yes.
Synthetic oil or bio oils will replace extracted oil in the near future?
Good question. So I'll talk about that a little bit later on. So let me just finish this, and when I come to the end, if I forget, just remind me, because I have a little part where I addressed bio-based oils coming down to the end. But just to quickly answer, just to give a general answer, not in the immediate future, because the bio-based oils don't have a lot of this oxidation stability. So they tend to oxidize faster. So you find them more used in the hydraulic type equipment where the temperature really doesn't rise above 40 degrees Celsius, and not in engine oils at the hotter temperatures or turbine oils. Right? So, and of course you always have the same thing like biofuels. You always have the argument is either food or fuel. Because remember, you use fuel to make the alcohols which you burn as fuel. So as always the little argument there. But good question. The manufacture of Group 1 base oil. So just to give a little overview, you preheat the crude oil and then you send it through the fractionating column. So at the top, you have the gases, you have the natural gas, the propanes, the butanes. Propane and butanes are the LPG. And then you have some gasoline types or the naphthenic types coming off. Then you have the different streams, the kerosene and the diesels, or the different streams that used to make kerosene, diesel. And of course, fuel oils. Of course, this is very simple, very simplistic. The residue from this is heated again, and then it's vacuum distilled. And when you do vacuum distillation, you get you got some more diesel, and then you get some more, and then that's when you get your lubricating oils, and then whatever remains there is your, I think that might be like your bitumens and that kind of thing. So it'll be very, very thick and viscous. So in a sense, so in a nutshell, this is basically the group 1 base oils, the manufacture. So base oil manufacture for group 1, you have solvent refining. So the separation processes are solvent based. So the solvents remove the aromatics and the solvents remove the waxes. And it may include a light hydrofinishing at the end, and that's basically how you produce group 1 base oils. Right, and of course, these were the first types of base oils to be used. The hydroprocessed, so this is for group 2 base oils, group 2 and group 3. And of course, the difference between group 2 and group 3 is the severity of the hydrocracking or the hydrotreating. So this is where you have molecular conversion. So you have hydrocracking, you have catalytic dewaxing, and you have hydroisomerization, all things that you can find on the internet. And of course, this produces the group 2 and group 3. The difference here is, so basically what you do here is like you take it's like you're using a group 1 base oil and you're improving on it to form the group 2 and the group 3 base oils. And just to give a little idea as to how the market works, when there was a switch, so there were a lot more group 1 base oil plants in the world, around the world, and of course, we get a lot of supplies from America. So our major suppliers from America, with their emission controls, the older plants were group 1 plants and the newer plants were group 2 plants. So somewhere around 2007, they actually had a switch in the market, and it was an oddest thing where group 2 base oils were actually cheaper, better quality, and more expensive to produce, but they were actually cheaper in the market than group 1 base oils. And it was based on demand, because all the manufacturers were using group 1 base oils at the time. And all the additives they had were designed to use with group 1 base oils. And so they needed to switch. So for about a period of a year, group 1 base oils, which was a lower quality, was actually selling more expensive than a group 2 base oil. Of course, that has normalized with the shutting down of more group 1 plants and the opening of more group 2 plants. And of course, manufacturers, lubricant manufacturers like the NPs of this world, you know, they switch from group 1 to group 2 base oils. So try to give a little, you all can see the pictures there, right?
Yes.
Nice. Right, so I use a little example there. So you see the group 1 base oils, obviously the lighter one is on the left, and as a light base oil is almost like water. And then of course, as it gets thicker or more viscous, you tend to be a little bit browner. The group 2s on the top basically are the equivalent in viscosities to those group 1s, and you notice it remains very clear. So it would have improved in purity. So for the same viscosity oil, and I'll give you the NP's experience, how much people pay attention to color, even in the industry. When we switch from group 1 to group 2 base oils, when we were mixing or blending the heavier viscosity oils, so you have like, you know, your lighter oils is like a ISO grade, so like a hydraulic 32 or a gear oil 32 or a gear oil 46 or 48. And then you have the higher gear oil viscosities like the 460 and even like the 100 or the 150s. When they were looking at the 150, because they're accustomed seeing something brown looking like the one in the middle, the group 2, and then it started to look mostly clear, they were like, well, it looked like something went wrong here. And, you know, we got a lot of customer calls, and then we had to write a lot of letters on. So the group 2 base oils obviously has a lot better, and the group 3 base oils have a lot better oxidation stability because of the severe hydrocracking. It would have knocked out or broken up the naphthenic type molecules or the aromatics and created the more paraffinic type molecules, which are more oxidatively stable and can be used at higher temperatures for higher periods of time. and of course can be used for longer in your units. The production of hydrocracking. So the production of olefins is basically steam cracking of hydrocarbons. They produce light. So the main route for producing light olefins is using steam cracking of hydrocarbons, right? And of course, the feedstock comes from the refineries, so crudes, so the light ends, and of course, it comes from the natural gas field as well. So the sources or the raw materials for the polyalpha olefins really comes from the refinery. So you have the etanes, the propanes, the butanes, naphthas, which is similar to like the gasolines, and the gas oils, which are like the diesels, right? So that's basically where the how heavy how large the molecules are. You would have heard, may or may not, I guess a lot of you all drive, I'm assuming. When you change your oil, so I don't know, you probably would have heard the ad where a particular oil company was advertising that they were using natural gas to produce their lubricating oils. And this is the natural gas process they were talking about, to produce the polyalpha olefins from natural gas, from the natural gas feed. Obviously, this is very energy intensive and is very expensive to make. So you would find, even though they advertise that, it's not a high quantity. And of course, this is not manufactured in large quantities anyway. So is what they do, they really mix some of this into the lubricating oil and continue using like the group 2s and the group 3 base oils. So it's not totally, of course, you don't get that from the thing, but I mean, once you understand the process. Right, so basically this is the process. So you have the different crackers, your production units where you put the chains, the molecules back together. This product here is of course not the lubricant. This product is the base oil, the polyalpha olefin. Right, so why I included this slide is so that when you manufacture, or you have a manufacturing plant, is like not putting all your eggs in one basket. So if you could have more than one market for your product, you know, it mitigates your risk. So if there's a downturn in the industry, right, to whom you are supplying, it doesn't affect your business as much. So it's like when you have shares and you invest in the stock market, you don't put all you split your portfolio, some low risk, some medium risk, some high risk. So depending on how things go, or depending on which company falls or whatever it turns, you know, you still have, you kind of hedge your bets basically. So, so the predominant use of the polyalpha olefins are synthetic base stocks, and in addition to that, they make surfactants, right? And well, of course, they are aqueous. They're used for making aqueous detergent formulations. So a little bit of history of the PAOs, and why I included this slide is to kind of, because I mean, these are basically your university students, and what I wanted to show is that, you know, everything would have started with a small process, you know, moving forward. And of course, it would have started with experimentation. And you tend to hear most times, you know, you need to go to school, get a job, go to school, get a good job, and then you retire. And of course, more and more now we're realizing that, you know, it's like go to school, maybe you could start a business and take it from there. Right, so just to give a little idea, so when you see all the technology now, it really began years and years ago. So PAOs were originally developed in 1930, and the first commercial engine use, what the use in commercial engine oils was in the 1970s. It's made from ethylene gas, right, which is crude oil or natural gas dependent. It has a higher temperature resistance than mineral type oils, right, which I spoke about. The polyalpha olefins can be used up to approximately 160 degrees Celsius continuous service, and intermittently, so different parts of the unit could go up to 270 degrees Celsius. To give you an idea, the engine in your vehicle typically runs at about a little less than 100 degrees Celsius. Right, so 160 degrees Celsius is a pretty high temperature. Keeping in mind that, and as a rule of thumb in oxidation, the rate of oxidation of the lubricant doubles for every 10 degrees Celsius rise in temperature. Right, rule of thumb. So from 100 to 160 degrees Celsius is a lot more severe operating condition for the lubricant, right? And that is where the POs can adequately protect the equipment. The PAOs, because they are manufactured, and as a manufactured molecule, it has no wax, and therefore it has excellent low temperature properties. So it could go down to minus 50 degrees, minus 60 degrees Celsius, right, before it starts to affect the flow or reach the freezing point. Of course, this is important depending on where it's being used. So depending on different countries, you know, if you have vehicles being used in Antarctica, you don't want to be using mineral type base oils in those instances, because they'll just freeze once the engine is shut off. It has a higher viscosity index of approximately 130 to 140, right? Mineral oils are typically at about 100. And how they came up with the viscosity index, just to give you a little, so because I think I'll use the term a few times. They use two base oils produced from different regions. So I think one is from the Gulf Coast, and I can't remember. It's two different areas. So they consider one having a viscosity index of 0, and they consider one having a viscosity index of 100, and then they compare them. So everything, so they plot a graph, and then they compare the change in viscosity, and that's where you end up on the graph. So the 130, the 140 has no units. It's really just an index, which is what it says, a viscosity index. The PAOs are less volatile than mineral oils, obviously, because all the molecules have the same size. And so once you start to heat, so for instance, if it's a mineral-based oil and it's manufactured using the distillation process, you have a range of different molecules. So once you start to heat it, the lighter ends start to go off, or the lighter molecules become volatile, they go off into the atmosphere. And of course, that leaves a heavier end. Now, that affects so being volatile affects the flash point, but it also, being volatile affects the flash point, and it also adds to emissions. And especially in countries where they measure emissions, even if you have it in an engine and it runs, it will get out back through the exhaust, and it will add to the emissions. And of course, you know, you could be charged in other countries for having high emissions, right? So that's why there was a switch to, or the move towards synthetic type oils. It was really emissions driven. And of course, with less emissions, it means it's less flammable. And the other risk is that when the lighter ends go off, it leaves the heavier molecules or the larger molecules inside the unit, which means you end up with a more viscous oil. And it's not the oil. And you could, if enough light ends leave, you could change the viscosity, right? And it increases the viscosity of the lubricant in the equipment and could cause damage to the equipment eventually. Right, so the PAOs are compatible with mineral oils, so they can mix. So if you were to change from if your engine was using mineral oil and you wanted to go to synthetic oil, you can change the oil without having to use any engine flushes. In fact, engine flushes are not really recommended. So you could just drain the oil and then fill in your new synthetic oils, even if it's the poly-alpha olefins. It has a lower natural lubricity than mineral oil. And the odd thing, if you remember the API, the 1509 publication, it spoke about the amount of sulfur. So those sulfur elements actually add to the lubricity of the mineral type oils. So PAOs, because they have no sulfur, tend to have a lower natural lubricity than mineral oils. So the PAOs, you need to add different types of base oils to it to enhance that property, or to develop additives that make it more, increases its lubricity. The other problem is the PAOs are very non-polar, and so it has issues with solvency when it comes to additives So the typical additives that you use for the mineral type oils cannot be used with the polyalpha olefins, and of course they need to do some experimentation with the different molecules to be able to make it soluble. PAOs, interestingly enough, form hard deposits in reciprocating compressors, and to tell you the truth, with all the technology that we have, they still have not really figured out why. And they tend to find it in turbine oils as well to a certain extent. So that's still a place where a lot of research is being done. And the funny thing is not all pieces of equipment show it. So PAOs, as I said, they must blend a certain amount of ester-based oils in it. Of course, this affects it helps with the solubility of other of the additives. It helps with lubricity, and it's a swell agent, basically. Now, the PAOs, most of the seals are nitrile type rubbers, and if you use the mineral oils, of course, they work fine. The PAOs tend to shrink the seals, and this is something you need to pay attention to. You know, if you're switching from mineral type oils to hydraulic oils, to PAOs. Of course, with the cars, you don't really have to worry about it because they would have made the seals compatible with both, because knowing that they both exist on the market. But if you're in the industry, this is something you need to pay attention to, because you know the tendency is towards the synthetic type lubricants. Interestingly enough, the PAOs are not biodegradable, and it costs 4 times more than mineral oils. However, it costs less than some other synthetics. So the interesting thing here is that when the synthetics originally came out, they used polyalpha olefins as the base stock. And of course, it's more expensive. So, of course, you know, I mean, it all comes down to money at the end of the day. While it did, one company, can't remember which one of the oil companies, or one of the major oil companies, developed, so they used the technology, developed the technology with the group 3 base oils. So they severely hydrotreated the group 1 base oils and knocked out a lot of broke up a lot of the aromatics and formed the long chain molecules, which are more oxidatively stable. And they started to use that and sell it as a synthetic. Now imagine you have the one company already in existence selling synthetics with the polyalpha olefins, the real deal, you're using it in your vehicle. Then you have a competitor coming on the market, and they're selling it for almost the same price as you to the customer, but it costs, the base oil costs quarter. The base oil cost is a quarter of what you're paying. So obviously they'll kill you, and they could go into a price war, and you just wouldn't be competitive. So in fact, this went to court, and it was ruled that because they were marketing the group 3 base oils as the synthetic as well. And for a long time, even in Europe, they did not consider group 3 base oil synthetic. In Europe, they considered PAO synthetic, and group 3 was a mineral type oil. In the US, that's where it actually happened, in the US, where they started to sell the group 3 base oils as synthetic oils. As I say, it went to court, and the judges ruled that because the group 3 base oils do not naturally occur in the environment, it is considered synthetic because there has been a certain amount of processing. As I say, it doesn't exist. So it took a while for the Europeans to change, but eventually everybody kind of switched to the group 3 base oils, because it really, for the average user, so for me, for the average user using a PAO or using a group 3, I can't tell the difference, right? Once I follow the oil chain intervals and that kind of thing. So any questions so far? Because that was base oils.
So I have a question. You
Sure.
mentioned that it's not recommended to do an engine flush, right? Is it that the engine flush gets rid of the residual oil and that could cause a problem with your gears, or?
A good question. The reason why we don't recommend engine flushes is because, okay, so the engine is a kind of complex, is a complex equipment. They have you have high pressures, you have metals rubbing against metals. Even the pistons. So sometimes you have metal to metal contact because the pistons go from top dead center to bottom dead center, right? So the pistons move like this. Now to create the hydrodynamic wedge, you have the rings, and the rings move, right? Because they're free to move inside between the piston and the cylinder. So it needs motion. It's just like similar to hydroplaning on the highway. If you drive slow enough through it, your tire would be in contact with the pitch. However, if you go fast enough, you'll get hydroplaning, where you get the hydrodynamic wedge, and it gets between the road and the rubber. And so the road and the rubber never meets. So that's the hydrodynamic lubrication. So when this piston is moving top to bottom, at the middle, you have a lot of motion, so tick, but when it reaches the top, it has to stop and come back down. So the the velocity reaches zero. So you actually have metal to metal contact. And you have you have your bearings. Remember, your bearings need a certain viscosity. And again, these are the bearings. You could have, if the oil film is too thin, you could have metal to metal contact, and it will cause wearing in your bearings. So that's why you have the oils. Although the oils are going down lower and lower in viscosity. That being said, if you need all these lubricants, and these are some of the additives in the lubricants, and you need these highly developed and technologically advanced lubricants compared to years ago in the engine, put in a flush into it. The flush is really a solvent. So you're running it without any viscosity. You just put in a solvent in there, it pumps through. Yes, it cleans, but then you get metal to metal contact. So that's why they tell you just, I don't know if you ever read the instructions. Basically, you are to start the engine. You don't ever rev the engine, and you just leave it running for about 5 minutes, if so much, or 10 minutes, and then you drain. Because it could cause damage if you run that for long enough.
Okay, so that's after an oil change or like during the oil change?
No, they normally recommend the engine flush. People tend to flush right at the oil change. So maybe you had a little bit of sludging, the oil was a little bit, you leave it for a year and you didn't change the oil. Sometimes it's recommended by mechanics too. Sometimes you're switching lubricants. So, I'm moving from some brand to another brand, and you say, you know what, I need to get our old one out. So just to start back fresh. But the engine is designed so that most of the oil comes out anyway. So you could just top up with the next oil and then continue going, rather than recommend that with even industrial type equipments, because sometimes you need to flush, when you're cleaning and you take the equipment down, or if you're commissioning, you fill it with actual lubricating oil, you circulate that so it doesn't damage anything, and then you flush the lubricating oil, and then you put in the proper thing once you get the proper cleanliness, and then you filter. So it's not really recommended. So the base oils, as I said, so that was the one part of it. The other part is of the lubricating oil additives. So you can see the amount of work that goes into it. So there are different types of additives. There are detergent type additives. And these neutralize combustion additives, acids, reduce piston deposits. They basically keep the engine clean and neutralize acids. You have dispersant type additives that keep, like when you have soot or any varnish formation or sludge formation, it keeps it from clumping together, because once it starts to coagulate and clump, it gets heavy and it drops. Right, so you want to prevent that from happening. So the dispersants keep it in suspension and keep them from clumping together until the oil can be circulating through the oil filter, and then you knock it out. You have things like antioxidants. Obviously, this improves the thermal stability of the oil, and it reduces oil thickening, because when the oil oxidizes, it starts to thicken because the chains start to get longer and it starts to get thick. You have anti-wear agents. It reduces engine oil or engine wear and scuffing, and anti-wear agents tend to work by tacking attaching to metal surfaces, and so it forms like a sacrificial surface. So when you have the metal to metal contact, you have the sacrificial surface wearing and not the metal itself. So of course that gets used up. Right, you have anti-foam agents. These control foaming. So obviously you don't want stable foam to be forming, because air has no viscosity basically. So you don't want air getting through your system. So once it comes up to wherever the reservoir, the sump is, you want all the bubbles coming up to the surface and bursting quickly. You want rust. You have rust inhibitors. Obviously, it prevents rusting. 4-point depressants. These improve low temperature performance. viscosity index improvers, or these like the multi-grade oils, and it improves viscosity. It maintains the viscosity, so there's less change in viscosity over a wider range of temperatures. The interesting thing here too is that some of the additives actually work against each other. So you have detergents that try to clean metal surfaces, and then you have anti-wear agents here. And the most widely used is zinc dialkyl dithiophosphamate. And these tend to attach onto metal surfaces. So you have directly two additives working against each other. So that's why when you develop the formulations, it's a very tight balance. To give you an idea of the business, so there are 4 main additive suppliers, and they were formed from the multinationals. So before, every multinational had their own research and development. They developed their own additives, but it's very expensive to develop, and is very costly. So they formed these companies. So they actually partnered and formed these companies, these 4 companies. So they in different combinations inside it. And so they form these companies, and these companies sell additives to the different manufacturers. So NP would be buying from these brand name manufacturers. And of course, there are numerous smaller additive manufacturers worldwide. So the manufacturing of lubricants. So I spoke about the crudes a little bit. We spoke about the different types of base oils coming from the petroleum based. And we spoke a little bit about the additives. So the additives, so you have the different additives, they combine them with the base stocks, and of course they form the different lubricating oils. So you have the engine oils, the transmission oils, hydraulics, greases, cutting oils. Right. I think you should be able to see a typical oil manufacturing process there. So the first thing is the blend formulation. So you need to know exactly, now normally the additive manufacturer tells you how much of the additive to use and which additive and which base oils to mix with it to get the different viscosities. So the cues that you see are quality checkpoints in the system. So our first quality checkpoint is the blend formulation. So you ensure that you have a good formulation. The base oils that you import and put into your tank farm are checked. So you check the quality before it comes in, because you know exactly what the viscosity is. You check the quality of the additives because they come with a material safety data sheet to ensure they have all the additives. It goes into blending tanks. After it's blended, you do a quality check to make sure that it meets the specification of the actual lubricant. If it doesn't pass the test, it goes to the blending tank. It goes back to the blending tank and is corrected. Once it passes the quality check, it goes to holding tanks and then goes to filling. And normally the first container to be filled, whether it's a drum or 1 liter quart, it is checked for quality. Just after blending, it might just go into holding tank. So you might have it there overnight and then fill it the next day. So you want to make sure the right product goes into the right labeled container. I'll talk a little bit about the applications. So, right, so remember we were talking about the engine oils. So this is a typical 4-stroke engine. Right, so you have the different strokes, and of course this is the top dead center here, and then the bottom dead center here, the exhaust. Right, so yeah, you have to keep in mind that in this one piece of equipment, there are different types of lubrication that are required, because you have sliding type friction where surfaces rubbing against each other. You have rolling type friction where the common follower is. So the common follower, that allows the valves to lift. Right, so that's metal to metal contact. Sometimes you might have bearings inside there, so you need to, that's roller bearings. You might have ball bearings. So there are a host of different things that go inside there. So when the manufacturer recommends a particular quality of oil, it really needs to just do a time check there. Right, you really need to use the quality. So there's a change in operating conditions. So normally you tend to have a high power to weight ratio. Higher power to weight, so smaller engines producing higher powers, working at higher speeds, they're operating at higher temperatures. The car designs are changing, they're becoming more aerodynamic, so that means less air is flowing over the engine to cool the engine, and more air flows around the engine. You have a lot more city or traffic driving, that is harsh driving conditions. You have emission controls, and of course, you have specific engine tests to guarantee performance. Right, on the diesel side, you have the diesel engines. So diesel engines are similar to gasoline engines, except they operate at higher pressures and temperatures. So there's a lot more, in addition to that, especially if you're using, well, of course, the sulfur levels are a bit higher, unless you're using ultra low sulfur. So that forms sulfur dioxide, which when it dissolves with water forms sulfuric acid. So the oils need to be a lot more robust than gasoline engine oils. Automatic transmission fluids, why, and again, everybody has a car and interested, but these are actually, automatic transmission fluids are actually the most complex types of lubricants because they have the most amount of additives. And so you have different types of things in there. You have the torque converter, you have the different gear trains, you have the clutch pack, you have a hydraulic system that has to be able to cool. So you really need to ensure that you, and of course you have different makes too. You have the double clutch system, you have the CVTs, the CVT type transmissions. So it takes into consideration friction performance. Of course, when you change a gear into drive, you don't want to get a jerk, or you don't want to be, you switch it into drive and it takes a while to engage. You want it nice and smooth. You want the gears to change nice and smooth. You want efficient power transmission, good gear lubrication, has to be able to transfer heat, so to cool. Has to have high oxidation resistance because nobody changes their automatic transmission fluid. And of course, you should be following your manufacturer's specifications. So when you manufacture, you normally manufacture to a specification. So there are a host of different specifications. You have the German Steel, you have AGMA, which is the American Gear Manufacturers Association, US Military, you have the American Petroleum Institute, JASO is the Japanese spec, the ACA is the European spec. And of course, you have a host of different OEM specifications. So it depends on where you're blending and what it is you're blending. So lubricating oils are one. I'll touch on grease a little bit. So a grease really is a solid to semi-solid dispersion of a thickening agent in a liquid lubricant. Basically, what it means is that there's a matrix and you put the oil inside the matrix. So it's like a sponge. So grease is like a sponge with oil soaked into it. And when it needs lubricating, so when it is pressure, it's the oil releases, it lubricates, and then it goes back into the matrix. Right, that's basically how grease operates. These are the different grease numbers. So it runs from a 000 to a number 6 grease. And of course, the lower the penetration, so a cone drops into the grease at this temperature. And of course, the stiffer it is, the higher the number. A little bit about the grease manufacturing process. So NP has a grease manufacturing plant. They use the saponification reaction. So we use a fatty acid, hydrogenated castor wax, or sometimes 112 hydroxystearic acid, and it reacts with an alkali, and that's why you get different grease types depending on the metal in the alkali. So a lithium hydroxide reacting with the hydrogenated castor wax will form a lithium type grease. And then, of course, the calcium will form the calcium type grease, the potassium type grease. So once you cook it in the kettle, once it comes up to temperature and the saponification reaction finishes, the lubricating oil is added, it's quenched, and it's absorbed into the matrix. Right, and then after that, you have milling and you have some different processes, and then you put in the additives. So the greases, as I say, it depends on the method of lubrication. You consider things like operating temperature, penetration range, of course, as the stiffness of the grease, how thin or thick you want it, depending on the speed of the equipment. So the higher the speed, the thinner the lubricant you use, loads and any other special factors. In addition to that, why you want to use grease? So like you typically find for like your wheel bearings, because they're in dusty and dirty environments, you tend to use the grease, because the grease, even if you have any ingress or any dust or dirt particles get past the seal, it would stick right on the grease right on the outside and prevent it from getting inside the bearing and causing damage. Right, so that's really the purpose of the grease. So I think I'm doing okay with time. Coming to the end of the presentation. So the global, I decided to touch a little bit on the market. So the global demand for lubricants is about in 2019 was about 37 million metric tons. More than half of that, about 57% of that really is for the automotive sector. So the engine oils, the transmission oils and those things. The three largest lubricant markets: China, USA, and India, right? So you get an idea of what the market looks like. With respect to threats to the petroleum-based lubricant, and this is where you were asking about the bio-based lubricants. So longer oil drain. So first of all, the lubricants have longer oil drain intervals due to better quality lubricants and better quality fuels. So even for the diesel engines, and you have ultra low sulfur, you do have a lot of sulfur, which forms the acids and forms a lot more combustion particles that could damage bearings. So you could run the oil inside there for a lot longer. And remember, we spoke about the quality of base oil. So once it's more oxidatively stable, they can last longer inside the engine. You have the increasing use of bio-based lubricants in the industrial sector. And again, this is typically for the industrial sector because they operate at a lower temperature than like the engines. And of course, these are driven by environmental laws in the US and Europe relating to degradation. And this same law is a restraining factor for synthetic lubricants, the polyalpha olefins that I was talking about, that is not biodegradable, right? You have the advent of electric vehicles, and from the way things look, I mean, you see the European countries saying, you know, they're going to ban internal combustion engines past 2030 and 2040. So the French, I think the English made certain statements like that. So you find Europe heading that way. Now, if that happens, of course, it means the demand for lubricants, right, based on the values I gave before, is going to reduce. And of course, we have the pandemic going, where you have reduced amount of driving, where we have seen a reduction, and reduced amount from the manufacturing sector, or reduced requirement. The reason why I brought these things up as well, and remember I was speaking about, so the opportunity here. So where's the opportunity in all this? And that's why you always have to keep looking, you know, wherever you find yourself. Where is the opportunity? Because it looks like something that's dying is going away. The opportunity, as I see it, is you're going to have a gluttony market. And once you have a gluttony market, of course, it reduces the cost. The trick now is to find another use for it, right? Because if it's going to electric vehicles, and even on the petroleum side, so the lubricants is one, but the fuels as well, you'll see a drop in fuel consumption, or the hydrocarbon fuels consumption. And if that's the case, and then of course you have solar energy and all those things, right? What is the opportunity there? What can we use these things to make, right? And maybe we could have, and it's something interesting. I don't know how much of you all would have read the national budget, but the national budget, the Minister of Finance basically stated that, so of course there's the local stock exchange. So he said if you're on the stock exchange and you could raise between $5 million and $50 million, well, of course, TT, and these were the small enterprises. And of course, you know, you could start small. And of course, if you have a good idea and you could prove your technology, I mean, you could get investors. So you don't have to actually have the money yourself. You just need a good idea, and then that's where you get your money. You could start something, you could start the business, and the benefit of it, they give a tax break. So I think you pay corporate taxes 30%, if I'm not mistaken. And they said if we could raise between $5 million and $50 million, you pay 10% tax for 10 years or something like that. So you understand the government has been putting things in place so that we could start different things, and we could start moving away from, you know, this is how it is, and because we need to change. And your generation is the generation to change it. So I think I did, and that's the end of my presentation. Apart from Brian, I didn't really get any questions. Any questions now, though?
We do have one question here from Evangeline in the chat.
All right.
The process of developing synthetic and bio oils, is it a costly process, and how does it compare to the costing of conventional hydrocarbon extraction? So
of course, because the system is geared towards the extraction of mineral oil, and again, so there is a certain amount being produced, and of course the volume is there. To produce the synthetics, it is, so like the polyalpha olefins, it is more expensive. And some of remember the group 5s that I was speaking about, some of them are even more expensive because there's like polyol esters and all those things. So Those things they're very energy intensive to produce. So you might not find them going away initially in the first instance. So the mineral oils are really cheaper, to answer the question. And it is more expensive to use the synthetic. In fact, if you in your normal engine oil, if you go to buy the mineral oils are about what, $40, $45, $50 a liter. And the synthetics are about $70 a liter, right? So they're a little bit more expensive. Bio-based lubricants, of course, can't be used for engines, and they're more in the industrial sector. Now, first of all, the bio-based lubricants are not very oxidatively stable. They're plant-based, and so they're not very robust. So you can use them, but they have more frequent oil changes. And I'll tell you something, and there are some articles, and of course, you know, there are always pros and cons. And what they were saying is, even though, let's say you're using it in the middle of a forest somewhere, cutting down trees, and there's a leak in the hydraulic system, so you have a rupture and it spills all the oil. They say it basically is like a similar type oil. I mean, obviously it will degrade, but it could cause death to some animals, I guess, in the short term. So the bio-based lubricants needs a lot more work to become oxidatively stable to be used at the high temperatures as the engine oils and the mineral oils and the synthetics.
I have a personal question. So it's a personal case study. So let's say there's a vehicle 7 years old, gasoline, and you want to change your oil from one brand to the next. And so given that you said the oils with the POAs in it, they are more protective than oils without the POAs in them, what brand do you think should someone go to for that age of vehicle?
How old is the vehicle?
7 to 8 years around there.
You could use 7 to 8 years. You're safe with using to tell you the truth. So before I came NP, I worked two other places, PTSC and Carney. And of course, this was I would have joined NP a while ago, so in 2000. So before I came, I just bought my first car. Of course, a used car. And I switched to synthetic because I was like, only synthetic go and work for this, right? Granted, a used car. And that's my first car. When I went to NP, I realized, I say, you know what? Because, well, of course, lubricants. I was in the technical department initially. So I did all the reading, and then, of course, I did all the technical seminars and that kind of thing. Then I realized, you know what? So my next oil change was a mineral oil. So I started to use in fact, I didn't even use NP oil. But when I went to NP and I realized they have a good quality oil. So I switched to the mineral type oil. Look, right now, my wife's car is 12 years old, and that uses mineral type oils. The car I had before that was mineral oils. The one I buy now is a hybrid. So I use the synthetic. My NP has a synthetic oil now. So to me, for me, I mean, once the car, I mean, the new cars now, obviously you need to use the synthetics because like it's a 0W20. So I don't want to play around with it. And of course, I have a lot of electronics on it. But a 7-year-old car, I mean, the mineral oil is fine. If you want to use the synthetic, again, is more cost. But I'll tell you something. Remember I was speaking about specifications. So the API, and I mean, you could always email me after. So the API, or give me a call. I think I left my number there at the beginning. The API sets the specifications. So even if it's a mineral oil or a synthetic oil, it says API, I think it reaches SP. So it would have started with SA, which was just a base oil, SB, SC, SD coming on the road. They reach SP now. So whether it's a mineral, no, I don't think mineral oils can make it there. No, group 1 oils can't make it there.
And rating on it? No.
Yeah, there's a rating. So once you use the correct rating, whether it's a mineral or synthetic, you're fine. Okay. The synthetic part is just the marketing part of it because it's more expensive. And of course, put in the people's mind, well, you know, the synthetic is better. As I told you, I was using, before I learned all these things about oil, I switched from mineral to synthetic. And then when I went to NP, I switched back to mineral. Okay.
Now I could say I get advice from a lubrication connoisseur.
So to speak.
Okay.
I have my contact as well. I have the 2 emails there, so you could always.
Okay. I'll definitely do that.
And for anybody else too. I mean, I don't think a lot of the other students had any questions, but feel free to contact me.
Okay, no problem.
And any other questions, sir?
That's it for questions in the chat. I don't know if anyone wants to ask any questions that they think would be relevant. Feel free, guys. He's a cool guy.
Exactly.
You mentioned that you previously used synthetic, but then when you join NP, you switch to the mineral. So really and truly, the difference between the synthetic and the mineral is not really that much of a difference. And the mineral is cheaper, so that would probably be the better one to go with. And so like it's just a marketing thing in a sense, in terms of the synthetic. Once you use the proper rating and thing, you should be with the mineral.
Correct. And I'll tell you something, but as I say, with the new cars, as I told you right now though, and so that was back then, of course, that would have been before you all were born, or when you all were babies, come to think of it, because that's 20 years ago. So the car at that time was a B12 Sentra. And so obviously it didn't have a lot of electronics, and I mean, it could work safely. And of course, the marketing was a little bit different then. With the new cars, I would recommend, now if you have to use certain viscosities, it will be synthetic. Like for instance, right now, you wouldn't find a mineral 0W20, a 20 body oil. That's why I use in my car. No, but NP makes we have a hybrid oil, right? So if it's a new car that you're buying, you probably want to follow the manufacturer. You always want to follow the manufacturer's recommendation. Right? And if you need help with that, you could always call NP. We have the technical people, and you could contact me as well, and then we find the spec, and then we'll be able to say exactly or recommend something for use. So of course with mine, so like this one, I wouldn't use a mineral oil.
Okay, thanks so much.
No problem. So I hope I wasn't too painful.
It was quite interesting.
As I told you, this was the first one. So I was thinking when I was putting it together, I was thinking, well, maybe, I should, I don't know, have more animation or something. More video, but because it's always better when you're in person and you're interacting. But that's cool.
So I have a question.
Yes.
Can I select the types of oil, the bodies I just said, and you relate them based on the electronics of the car?
No, it's not based on the electronics. As what I was saying is that, so if you have when I had my older type car, it's easy to change the engine. You just switch the engine. Now to switch if you have to switch a hybrid, I mean, there are the batteries and you have the regenerative braking and all those things. So because of those electronics, I really don't want to have the engine to damage to switch the engine, because it's more complicated to do it there than to do it with the older car that I had. Even my wife's car. I mean, look, I mean, that's not a very electronic. It's not a modern car. So for hers, I can use it. So, sorry.
Understood.
Yeah, but again, when you use the lubricant, and whether it's if a car, and of course everybody interested in a car, or it's for a piece of equipment in your plant, you always go the manufacturer's recommendations, and it's always in the manual, so you always get it. Anything after that is marketing.
Okay. So it's now 6:34. Do you have any more questions? Going once. Going twice.
Hope everybody awake.
Yeah, sure. So the presentation was that good. It was that good. All right, so Mr. Motilal, if you could just unshare your screen, we have a certificate of appreciation to present to you.
Oh, sorry. Oh, well, look at that. Who would have thought?
Okay, Mr. Motilal, on behalf of the UTT SP student chapter, we'd like to thank you for this very technically insightful presentation and all of the advice which you would have provided us, and we hope to have you back here on another very insightful topic. Sure. And so we do wish you all the best in your endeavors, and we hope to see you soon.
Thank you very much for having me, and good evening to everybody, and good luck in your exams.
Yeah, thanks a lot. Thank you everyone for tuning in. Stay sure to keep in touch with our social media pages to be updated on any new events that we have. We have a lot coming this new year, so stay tuned and do enjoy the rest of your evenings. Take care.
Thank you.